Howdy, folks. How's everybody doing today? Sorry for the last minute change here. My poor little guy, he was not feeling great over the weekend. So we thought we'd give it a little bit of time and see. And then by the time we call Monday morning for an appointment, they're like, oh, yeah, come in at 5. And that's, a ways away. We actually left that place about like 6:10, but I have a half-hour drive home because, of course, it's not nearby because that would make too much sense or something. So I just got in the door like not too long ago. So hopefully this works out okay and you folks don't mind too much. Only being remote here. So sorry I couldn't be there in person. But it would be another like 25-minute drive back to campus from home. So I didn't think that would work out all that well. But we are almost done though. We have last bit of content for the semester on data visualization. And I'm actually not a big fan of Dr. Chuck's chapter. He does an interesting job showing lots of different examples, which is cool. And like, hey, here's a bunch of different things you can do. I like that, but they're not really like the easiest and most fun and straightforward for us to play with. So I think it'd be a little easier if we look at some other plotting. Thanks for the sound check, Brian. Appreciate it. Yeah, hopefully things are pretty well. I've been using my home office here for quite a while during the pandemic, so generally things run pretty smooth. And I have my second monitor right above, so I can watch all the chat, which is really nice. And so we'll see. Hey, Professor Burp, thanks for dropping on by. All right, so we're going to look at data visualization and plotting. Again, Dr. Chuck's chapter is great. Lots of cool examples like building out a map you can do, doing these little graph things, but it's all like download his code and hit run. It's not really a lot of interesting stuff that we can explore necessarily. Like word clouds are fun. So what I would rather spend some time doing is looking at making our own plots. Things like this is a little bit more interesting. But we don't need to go and get all this data out. We can look at some of our own data as we're going about this to see what we need to do for that. So let me fire up PyCharm here and take a look. Hey, Cotton. Thanks for coming on by. We'll start with a new project. This will be our visualizations. Now, there's a really great library we're going to use for this. We're going to need to import for the first time. So it is py plot is the library we're going to use. And it's actually matplotlib, the matplot library. There's all sorts of amazing things we can do with this. And so this is like their basic introduction tutorial. We'll take you through how you can work with some of this stuff, which is awesome. Actually, my friend, thank you so much for donating those bits to the Student Scholarship Fund with the University of Michigan Dearborn College of Engineering and Computer Science. So Snyder, the easy way for the final project for us, and what we're going to be looking at, is the player will only just do one action. They will either hit once or stand, because if your hand total is 4 and you hit and you get like a 5, and then your hand total is now 9, no actual player is ever going to stand at 9 because you're guaranteed to be able to get another card and not go bust. But if we start looking at that, then really we would have like no results for the low hand values, right? It's because what the result would actually be is once you got to a number that you might be able to bust at, and once you get to 12 or higher, then you start having the chance of busting and losing those hands versus standing. So it kind of throws off some of the numbers if we look at being able to hit as many times as they want. So all we wanted to do is say, hey, we'll just every other time we'll hit, every other time we'll stand, and we'll see which won the most or lost the least. Is generally how that's going to work. Because again, there's not really more winning when it comes to blackjack. It's just less losing because the odds are always in the house's favor. But the dealer does need that logic. So the dealer, on their turn, if the player hasn't busted, then they need to keep taking cards so they get to 17 or higher or bust. So we do need that sort of logic in that hand so we can figure out, did the dealer bust or did the dealer stop at a higher point than us? And that's why pretty much every strategy sheet you see, you're going to be taking cards if you're at 16 or less, because you want to get to at least where the dealer is. Now, if you're counting cards and doing all sorts of that other interesting stuff, those strategies can change. But and some of it even depends on what was the face-up card for the dealer as well. So if we looked at that was our Wikipedia blackjack, right? Blackjack from Wikipedia. Here we go. Their like basic strategy sheet that they've looked at here says, based on the dealer's face-up card, we might do some different things. So if the dealer has a 6, actually, then we are going to stand at a 16, a 15, a 13, even all the way down to 12, because it's most likely that they'll have a 6 and a 10 or something less, right? Which means they'll have to take another card, and then they're likely to bust at that point. A 6 and an ace is 17, and they can stop, and sure, but again, the ace is relatively rare in terms of the other 13 total faces that there are available. So you get to this sort of data, if that makes sense. So I think we're just trying to start a real low level, real basic, and then you can add in those other interesting things as you go. You're only ever going to hit once, Peter, because otherwise the result is not really having anything to do with your starting hand. It's, well, this is my current total. And then it's going to throw off the result of our numbers. Because if we're tracking with a starting hand, well, hitting and then hitting again and then busting is different than, well, I hit and then I hit again and I hit again and I got to 19 and I stopped. Like it's lots of different possibilities can happen when we start looking at, okay, well, let's keep taking more than one card as we go. And again, it's going to be stupid, right? You could have a total of 18, 19, 20, 21, and half the time we're going to hit anyway. Because that's literally the only thing we're going to do is half the time we hit, half the time we stand. So the data should show, hey, when we were at 18, 19, 20, 21, and we hit, we lost a whole lot more than we were at 18, 19, 20, 21, and we stood, right? Just a real basic level analysis here. Again, these are all great things we could do to make it better. And that's kind of this open-ended idea, like, okay, once I know this, now what can I do here? And how can I figure out better strategies and better results and that sort of thing? But just at a real basic level, and again, because we only had the 3 weeks to work on this, I didn't want anything overly complex for you to have to tackle there, that sort of thing. Excuse me. My allergies are going nuts here, too. It's been a day. It has been a day, my friends. So Monday, though, Monday. And we have 2 weeks until the fall semester starts, which is also crazy. That seems like it's starting so early. Anyway, so Matplotlib is fantastic. So I'll share this link in D2L, and there are all sorts of cool things you can do with plotting here. This is just like a basic introduction one. But we want the Matplotlib, we don't want the tutorials, we want the examples here. And the examples, like any kind of chart you can think of, essentially, is going to have an example in Matplotlib, because the amazing people who work in this library are amazing. And they have figured out all sorts of really cool things that you can do with it here. So again, we're not going to look at most of these at all, right? The amount of different graphs that you can do is just crazy. So if there's something you've seen before, it's probably out here in a way to graph it here. So all we really want to do is do some basic plotting to start, to kind of get the feel for, well, what is this here? So we'll just do a simple one here. So to do that, we need to import the library. So if we haven't used it before, we're going to go add that library. So in my project here, I'm going to go to my file and my settings, and I can go to my project Python interpreter, and I want to add a package. And again, this is that virtual environment copy. Matplotlib is probably fine for you to install in your main version here, but again, installing lots of packages in your main Python install is considered bad form because you don't want to have that cluttered up, and you don't want to have lots and lots of different packages that we're just kind of playing with. So that's the advantage of these virtual environments. But I'm going to hit add, and I want matplotlib here, and matplotlib.org. That looks like the correct one. There's all sorts of other cool things you can do off of this here. So I'm going to install the package. And we can click the link. Yep, made sure we landed at the right location here. Matplotlib.org, fantastic. And a lot of times to make things shorter, because it's py for Python plot, matplotlib.pyplot is long, you can use this alias import. Sorry, that's really small there, isn't it? You can say, hey, I want to call it PLT. So you'll see a lot of people do this sort of thing here. So I can just grab these 3 lines of code here after we've installed our package. And we'll drop these in. And I am going to, of course, be a good academic and set a good example here for you and say, hey, look, we got it from here, right? Sourced from, boom. Okay, so you know exactly where we got it. So what we do with the plot here is you give it the data to plot, generally in a list form, list or tuple form for the data to plot. And then you can give it some sort of label if you want. About us, yeah, I set the worst examples. It's okay. It's always something that's worth practicing. Now we give it a run. We finally are going to see something cool on the screen. We see an actual interactive, I mean, it's not really interactive, but it's a window. And then the library itself is really cool. You have a save button. You can save these graphs. Yeah, virtual environments, I mean, they don't add a lot of time depending on your computer. So I've got a nice solid state drive, so it's pretty quick. It does add a small bit of time if you're making them for every project. So sometimes I'll just have one virtual environment that I use for all the testing, but it don't matter too much. But you can save this off if you want to save it as a particular, kind of image file, and that's all fun things. But so that's a basic plot, right? So we're at looks like 0, 1, 0.5, 1.5. So we only gave it one axis though, right? Isn't that a little funny? We just gave it one set. We gave it 1, 2, 3, 4. 1, 2, 3, and 4. Then it kind of generated its own x-axis. Right, it's a little funny there, right? We should probably do a little better at figuring this out here. But that was the simple one here, right? And then we can look at a slightly more interesting one. We want, oh my goodness, there's so many options here. This is ridiculous how big it is. Just want a basic. I don't think we want event collection. Filling between the lines. Oh my goodness. We just want a basic line plot. A simple plot. Here we go. A lot of times people use NumPy. This is a really good library for dealing with numbers. And NumPy is good at setting stuff up for us. And this is kind of fun. It shows you all sorts of interesting things. But we can plot now the T and the S here on our graph. So T is the time. Or no, S is time. Right? S is the sine wave. T is the time. Yeah, so we're going from 0 to 2 in terms of time. And it's kind of broken it out for us. And it's going to graph that nice little pretty sine wave, which is fun. No, but these ones are a little weird. But if we wanted to do our own plot here, there's a really fun example here. Actually, we don't need to use. I'll leave those for now. There was a. It's called. Let me see if I can Google this here. It's linear thinking and non-linear world. I've Googled this a couple times before. Here we go. Yeah, it's a little Harvard Business Review article, which is fantastic. And it turns out people are bad at numbers, and you're probably not surprised here. But here's this example scenario for us to think about. So we have a company car fleet. We have SUVs, they get 10 miles to a gallon, and we have sedans, they get 20 miles to a gallon. We have equal numbers of each, and they both travel 10,000 miles a year. We can replace them with more fuel-efficient vehicles. Should we replace our 10-mile-an-hour SUVs, or 10 miles per gallon SUVs, with 20 mile per gallon SUVs? Or should we replace the 20 mile per gallon sedans with 50 mile per gallon sedans? Right? So which is actually going to be better for us? And, B seems more impressive, right? To go from 20 to 50, it's more than double, increase of 30 miles per gallon. But it's not. It's not here at all. And we can actually graph this out, which is really cool to see. So what we want to look at here is essentially the usage of gas. So what we have here, so we had, this was our SUV miles per gallon was 10, right? And then we had the SUV miles per year, we said was 10,000, right? 10,000 miles a year, right? So how much gas does the SUV fleet use? So this is gas used by, or we will name it SUV gas used per year is going to be my miles per year, right, divided by the SUV miles per gallon. It's pretty straightforward, right? We can see, okay, well, it's going to be 1,000 gallons of gas that we're using here for the fleet. 1,000 gallons of gas is a decent amount of gas. Not a ton, but a decent amount of gas, right? Okay, then if we look at our sedans, so our sedan miles per gallon was 20, and then again the sedan miles per year was still the same 10,000, and then our sedan gas used per year is going to be my sedan miles per year divided by the sedan miles per gallon. Nope, miles per gallon, right? And that one we should probably pretty quick in our head be able to know this is 5,000, right? So the SUVs used, right? We could print it out if we wanted. So our SUVs use my SUV gas per year, gallons of gas each year. Sure. And we'll do the same for the sedans here, right? So our sedans use gallons per year. And again, we'll skip this plot stuff here in a minute. We'll come back to that. So just looking at the data here, we can see 1,000 and 500. Okay, cool. That's a pretty quick comparison. Yeah, the separator is fantastic. I'm a big fan of that because it's really hard to see these digit groupings otherwise. So now if we wanted, we could just go right out to the future here. Not too big of a deal here, but that's we'll take a step back here. We'll take a look and see, well, what's going to happen as our miles per gallon increases here, right? So if we want to say our gas savings, then, right? So we might have a gas savings for SUVs. We're going to start as a list, okay? And then we're going to say for, this is miles per gallon, right? Miles per gallon in range of my SUV miles per gallon, which starts at 10. Let's just go up to 20 here, right? Because we want to go to 21 because 21 won't get us there. It'll be up to 20, but not including 21. Okay, so we're going to range there. And then the miles saved, right? The gas savings for SUVs. We kind of actually want two pieces of information here, I guess, right? We kind of need their miles per gallon and fuel saved. Right, so we could put in 2 pieces of information at a time into our list here if we wanted. Let's just do gas savings, and then we'll have it like a paired one here. This is miles per gallon here. So we'll make that one a list. So at oh no, this is miles per gallon. I don't know, we'll just call it a list. I have no better words at the moment here. We'll append the miles per gallon, right? And then our gas savings, we're going to append. Well, we need to do that calculation. So it's going to be my SUV's miles per year divided by the new miles per gallon, right? But we want to subtract the SUV gas used per year from that result, right? So figure out how many gallons we're going to use with the new miles per gallon and subtract it from how much it was using to figure out how much we've saved, right? We're using so many X less gallons of gas each year here as we go, right? So now we kind of have our 2 axes at this point, right? We're going to have the gas savings, and then we're going to have the miles per gallon, okay? So we need to plot it here. So we're going to have our plot dot plot, and we're going to give it some arguments here. Let me double check here because it has been a little while since we did some of these plots here. We give it 2, right? T and S. T is the first one, right? I think we give it the miles per gallon list, and then as the next one, we'll give it the gas savings. And then we'll call plot.show. See what we get here. See if we can get a result. Here we go. So at 10 miles, and I guess we should give it some labels here now, right? We can do that. Let me go copy out some of these labels here, because that's nice. So the X label and the Y label. And a title. Look at that. How pretty is that? Oh, should we do a grid too? Oh, do we have to do it on the subplot? I don't know if we can. That's annoying. How do I just set it? I don't want the axes. I just want plot. Yeah, here we go. So you plot. You go with the x-axis and the y-axis. This is the one I was looking for. And where's my labels now? Other parameters. I think we can give it a label in here. Axis label. Labeled data. I'm gonna add a label. Goodness. I don't want custom labels. All right, this is too annoying. Sorry. I'm sorry. We'll just graph it, and we can figure that out after. I think it was plot.set show. My goodness. We'll just Google it here. That's okay. So matplotlib add axis labels. Plot. X label method. Okay, plot.xlabel. There we go. Is that it? Plot X label. There we go. This is so our X is going to be our miles per gallon here, and then our plot.y label. There we go. Is going to be our gas savings. There we go. See if we can't make that pretty. Look at that. So in the miles per gallon and the amount of gas we're saving here, right? So to increase from 10 miles per gallon to 20 miles per gallon with the SUVs, we're going to save 500 gallons of fuel per year. It's pretty good, right? But now let's do the same thing for our sedans. So essentially, this is should do this SUVs here. So let me refactor rename this. Right, don't rename it yourself. Go to refactor rename. This is my SUVs, and let me rename that one too. It should be SUVs gas savings. There we go. I like that. All right, so now I can copy this we'll do the same thing for sedans now here. And sedans. So now we're going to go from our sedan miles per gallon. Sedans miles per gallon. No, what is it here? Sedan miles per gallon. Yeah, isn't that what I said? Sedan, no S there. So we're going to go up to, we said 51, right? Because it was going to go from 20 to 50 here. Go to our miles per gallon list, and then our gas savings here. This is our sedan gas used per year divided by the sedan miles per year divided by the new miles per gallon. So we're going to get some additional data here. So I'm going to add a second plot here then using my sedan mile per gallon list and my sedan gas savings. We're going to have two different plots here on the same graph. Right? We're going to plot two different numbers. So the gas savings for my SUVs from 10 to 20 are 500 gallons. For my sedans to go from 20, which I've saved zero amount of gas, to 50, I've only saved 300 gallons of gas. So it's not even close when we look at how those compare here. Because these are nonlinear. Right? The idea is it's not a straight line. You use less gas the more your fuel increases, your fuel efficiency increases, right? Assuming your driving doesn't change. Right? If you're driving the same amount as fuel efficiency increases, the amount that you're saving is more of a log form, right? It's really going to start tapering off here. Because if I could get 100 miles a gallon, great. To get to 1,000 miles a gallon, right, I'm not saving that much more than I was when I was saving 100 miles, driving 100 miles a gallon. Right? It's a very logarithmic looking graph here. And it's really fun to be able to throw some numbers out here in a list and just graph them. Right? It's actually pretty quick. And you could do, this one's probably not the easiest graph to use for your hit and stand and which one is going to give you best results here. But, you know, we have lots of options we can do plotting with. And again, there are so many things you can plot. It is like crazy how many different plots you can make. If you like statistics plots, all sorts of fun things here. Pie charts are great. Error bars, box plots, regular histograms, all sorts of amazing things here that we can do with our plots. The basic ones, sure. Right, scatter plots, bar plots. Yeah, here's our regular one. I don't know why they want this subplot thing for our example, but that's okay. That's all right. So most of it's just about, let's just give it an X, give it a Y, and go from there. Right, so let's look up a oh my goodness, it's just there, a pie chart. That's what I wanted. I wanted a pie chart. So with the pie charts here, right, it's going to, we just gave it some data here, 1, 2, 3, and 4. So 1, 2, 3, and 4, and it figured it out for us, which is pretty cool. Then you can do all sorts of other cool things with your colors and all sorts of other fun stuff here. We essentially just give it our pie here. And then we can set some other sorts of things if you want. You have all sorts of fun options here you can do with your pie charts here. So this is like the list. Yeah, this is probably a better one. And here's some examples of pie charts. You can do nested pie charts, labeling pie charts, all sorts of fun pie charts here. But just a nice basic pie chart here. So you can have labels, and then you can have sizes if you want. You can tell it which one you want to explode, like to pull out of that the view here, which is pretty fun. Let's see if we can't do a pie chart here. So we have that graph. We'll leave that one alone, and then let's try a pie chart here. So if we wanted to say, like, let's chart our calories throughout the day. I've been dieting lately, so that's been on my head. So trying to count calories and figure out when are we eating our most calories, maybe. So maybe we'd have a list of, this is what, calories per meal, essentially. equals a list, right? And let's say, okay, for breakfast we had, let's go Google this here. So calories in 3 eggs, right? 200, let's say 250, right? Not too bad here. And then let's do calories in, what's a nice light lunch here then? I'm trying to think of things I've been eating. Some sort of soup, maybe. How about udon soup? Okay, sure. 220 for this udon soup. It seems a little low, but that's okay. I think, what did this one have? Yeah, no, 230 for that one. I just ate. That was for dinner. So we'll do, how about 230 then? And then dinner is probably a pretty big dinner here. So let's do calories in, what do we want? How about a stir fry? Vegetable stir fry. Stir fry rice. Sure, so 350, and now with stir fry rice. How about with tofu here? Where do we get our calorie count here? It's carbs. My goodness. Friends, just give me a number here. That one seems low. Let's go like triple that. We'll say like 500. How about that? Sure, why not? Okay, so we have our calories, and then we need a way to add in our labels here, right? So our labels. So we have our labels is going to be breakfast, lunch, and dinner. And then how about a snack as well, right? Let's any other time we'll throw in snack, and obviously there's a decent number of calories in your snacks throughout the day as you start mindlessly eating things. So we'll throw that in. Okay, we'll make our pie chart. So we're going to call pie. So plot dot pie. Right? So give me pie dot pie, and we have to give it our data and then our labels. Right. So the first thing was our calories here, calories per meal, and then labels equals labels, right? Because you can assign these are optional labels here. All these other things you can do are going to be optional values. We'll call it plot.show. See if we can't get that one to show. Maybe I shouldn't be using the. Oh, there it is. Okay, we just had to wait a minute here. There we go. And we can see, okay, dinner calories, breakfast calories, lunch calories, snack calories. Look at that. It's showing us some cool, here's a pie chart. It's not super interesting yet. Maybe we want to do this auto percent here, right? Probably to calculate our auto percent. That's probably a good idea here. Let's add that one in. Make that look a little nicer here. And auto percenting, awesome. Come on. All right, where's our the first graph? Here's our next one. Okay, so 40% of our calories came from dinner, 23% came from snack, and we didn't have to add any of this up, right? I mean, it wouldn't have been hard to add up ourselves if we wanted to calculate this. Do a quick sum and divide each one of these and calculate our own percentages, but it just does it for us because this is a common use case when you're doing your pie charts. Let's go for it. If I wanted to make a pie chart of enrollment in some classes, I could do that too. And I could go out to our online services or my OCC site, get some enrollment data, and go take a look and say, oh, where are students enrolling? Do they want in-person classes, online classes? And we could put out some pretty graphs and do something with it, I suppose. Now the funny, or I guess not the funny thing, the risky thing with visualizing data is that it is easy to be misleading when it comes to data. And there's a whole book, right? How to Lie with Data or something like that. Yeah, this sounds. Is that the name of a book? I feel like it was a book. I forget. That's not what I was thinking about. That's what I'm supposed to do. Oh, there's a really good article somewhere. And it's showing you can very easily mislead. Was this it? The Huffington Post? Yeah, here you go. So if you want to show something and make it look very different here, this is interest rates from 2008 to 2012. wow, that looks like a huge difference. But if you have more of a fixed axis here, going from 0 to 3.5, they look about the same because the difference here is only this minimal from 3.14 to 3.15. That is like a 100th of a percent, right? It's like that change is not really as big as you might think here. Um, Current tax rate, 35%. If the tax cuts expire, 39.6%. Wow, we're like 4 times the taxes. No, our scale started at 34 and went up to 42. Like, this is sure. His pitch velocity from 77.3 to 75.3. Why is that like half the size of the other bar here? I got nothing. So, um, you know, cumulative annual revenue. Cumulative. That's the sum. This is annual revenue, not cumulative. But look, it's still going up. We're still making money, but it's like tapered off. Oh, wait, we're making less money than we were years before. So you got to be a little careful here when you do these sorts of things. This is a pie chart. 70%, 60%, 60%. That doesn't add up to 100%. That's not how pie charts work. So, yeah, you can do all sorts of fun things here. The axis here is upside down. That, wow. That one hurts my head. That, like, literally backwards here to make it look like it's gone down. But no, it's upside down. Closer to the top is 0. What? So, yeah, this, that sort of stuff, you can tell a story with data, and I think that's one of the most interesting things that we do in data science. Really, is you tell a story with your data, and you say, okay, we have a bunch of data, we've looked at it, and we've analyzed it, and we've sliced it, we've diced it, and we've done these sorts of things, and we think this is what the data says. And you can present it in lots of different ways here. And I imagine that that's a decent criticism that people have sometimes about when we present things as our quote, it's the science, right? Well, it's our interpretation of the data. Let's be honest. The more often you can repeat it and you get the same results, it's a little easier to say, okay, it's probably not just an interpretation here, right? It's repeatable. But if we do one thing one time, right, you can take a look at lots of results and skew them lots of different ways, so sort of make it tell the story you want it to tell, and that's what you need to be careful about for sure. So I don't actually have too much more when it comes to visualization and plotting. I wanted to show you that was out there. We won't do a lab on it because we have final projects next week that are due, so I don't want you working on multiple things here. But keep that in your back pocket. You can go and explore it on your own if you want to graph anything. You've got tons of options for doing some graphs. We've got lots of fun things we can do with it for showing things. Let me make sure I go and commit this here. So here's our visualizations here. And then the plan was for the rest of the night to work on the final project. So we had that one last lab was due. I think I have everything in except for the project 4. I still need to grade project 4 for you. I'll be working on that in this last lab that just came in. So that was our last lab assignment here. And it will drop the lowest lab and the lowest quiz. So I think we have all the quizzes in. Those all should be graded, including the midterms for you there. The lowest quiz score will get dropped, but not the midterm. Hopefully that was obvious. What are the regular quizzes? We'll drop those, drop the Lotus Lab, and then our final project presentations. And you can present your final project. We'll take a look at the data. It's like 5 minutes or so. It goes up to 10 if people are really interested in talking about stuff, but generally about 5 minutes or so per presentation. We'll get those knocked out. We'll have a lot of fun next week. So the plan is to be in the classroom next week for anyone who wants to come in person, and then I'll have a Zoom session open instead of Twitch here, so you can actually share your screen. So we'll just meet on Zoom. You can share your presentation if you want to join remotely and do it that way. And just that last reminder, they don't get scored if you don't present them, right? It's not really points on the rubric, but they just won't be scored if you don't present, because this is my chance to actually talk to you about your code and ask you what happened, and it's I'd like to imagine it's generally pretty easy for me to tell who just went online and copy pasted something to turn in versus actually did it themselves when they were presenting it. And then I ask them about their code. So, it's, part of why I have people present, and it is really good practice. It's a good habit to be into, even if it's a little uncomfortable. I know it's not a speech class or a presentation class, but to present something essentially to your peers. I know I'm there and you're getting evaluated on it, but the idea here is that you just pretend we're a big software team working together, and you're going to present this to your team and say, hey guys, this is what I worked on. Hey folks, I put this together. Here's how it works. Here's the result we got out of it. This is what I was thinking. And here's some fun stuff in the code. Even maybe I thought this was fun, or I took this approach, and just go through it in some sort of like peer review style. And I'd like people to get more comfortable with that. So. All right. If you don't have any other questions or concerns, I'll flip this off here. I'll keep my Discord open, emails open, text messages open, and then we can just do screen sharing sessions from there if you're stuck on anything. But if not, we'll plan for next week, our final presentations at 6, and then we'll call it a summer semester. It's been a lot of fun, folks. I appreciate you coming along and trying the class out. And we'll have, I have to post it here, actually. I think I can go do that right now. A end of semester survey I need to put up here. Let me go import that while I'm thinking of it in my downloads here. I just need to change the date here because we use like the same package every time. So it is anonymous, and it's part of my annual evaluation process that goes to my dean. So it's the end of semester survey. It's pretty quick here, just a couple questions. Let me just change the timing on it if you don't mind. Starts today, sure, why not? Ends, and not actually today, but next week, 11:59 p.m. Sure, now let's put it in the calendar. A single attempt, that's editable. That was a bad import there. But let me give it a quick preview for you. So it's just, I think, 18 questions. So questions about the class, questions about me, some pretty straightforward, from strongly agree to strongly disagree sort of things. Those are all pretty basic. And then the open-ended questions. And I do try and take these seriously, and I have adapted. So before the pandemic, all the classes had some sort of like in-class exercise every week. And you do your in-class exercise like a lab assignment, essentially, like our labs. And you do that and you walk out the door. Most people got it done before they left. But they started trying to be a little bit flexible because, 4 hours a night is kind of a little rough. But then when the pandemic started, I said, well, that's dumb. People don't need extra things going on every week, right? We'll drop the labs. And I looked at the feedback I was getting, and they said, we want more practice assignments rather than just 4 projects and a final project. So like, okay, so based on the feedback, I put the labs back into all my classes here. So I was asking people how they thought, the weekly labs went, if that was worthwhile. They weren't designed to take up a lot of time, and I think a lot of you folks were able to get them done before you left for the night, and that's sort of the goal for it here. So, all right, yeah, I'm glad you like the practice. So, but you can fill it out here as well, and it is anonymous. So, questions about me, questions about the course, and just anything else here you'd like to fill out here. And it is anonymous. So, definitely, if you take a few minutes and fill it out for me at some point today, I'll post the link in D2L. Sorry, I got some itchy scabs on my arm here. Okay. Yeah, I think like a low stakes lab makes a lot of sense for some practice. Then you've got a chance to actually try something out before the larger projects here. And when it came to the labs, honestly, a lot of it is participation. Like if you're trying, and you got stuck on it, I've helped several people. Like I'm happy to help you answer the labs. Ian, what do you want? What do you want? You want to say hi? Here, come on, come say hi. Oh, baby. Oh, this is Ian. Ian, say hi to everybody. Say hi. Say I'm an old cat. He's I think 16 years old now. So yeah, happy to help with the labs. And so if you liked them, great. If you didn't like them, let me know. Or if you thought like one of them was like way more work than the others, happy to do that sort of thing. So yeah, 9 a.m. is ugly. I got into software so I wouldn't have to be up that early in the morning, Professor Perp. I guess 9 a.m. is not too bad, but I have always been a late night person, never a morning person. So, oh, kitty. All right. Yeah, that's all I've got. It's been a lot of fun this semester. This was honestly the first time we've run the course. It's brand new here at OCC. So again, would love your feedback here. How if you've taken other programming courses, how you thought it compared, and I'm open to your ideas. So thanks for everything. It's been a lot of fun. And next week it's your turn to talk. Ooh, homemade spaghetti sauce. That does sound good. Yeah, see you next week. Thanks everybody. Take care. I will see you around.